In this lesson, we are going to look at exponents. Now, most of you know probably what an exponent is, but we're just going to go over some of the vocabulary. So if we have this expression right here, we have a base and we have an exponent. The base is 5, that's the big number on the bottom, and 2 is the exponent, or sometimes it's referred to as the power. Now the next two examples get a little bit trickier, so we're going to be really careful here. On this one, the base is just the 4, because what that is saying, it's saying take 4, raise it to the third power, and then make it negative. Order of operations, you have to do exponents before that multiplication, and that negative is like multiplying by -1. So again, the base is 4, and the exponent or power is 3. So how is the next one different? Well, if you notice, the -4 is all in parentheses, and all of it's being raised to the third power. So this time the base is -4, and the power is still 3. What's the difference between these two? You would get two different answers. All right, if I have -4 to the third power, that means negative of 4 times 4 times 4, which would be -64. But if I have -4 to the third power in parentheses, that means -4 times -4 times -4. Well, in this case, you have an odd amount of negatives. It's still -64. But if that exponent was even, it would be different. Just be careful. Let's look at the properties of exponents. First property is called the product property. When multiplying the same base, and that's really the key here, you have to have the same base, you keep the base and add the exponents. So my base is x, I keep that, and I add the exponents. Because what that really means is x times x is x squared, and then 1, 2, 3, 4, 5, 6, 7, 8 is x to the 8, and look at that, I would have 10 little x's. So it works the same thing for the numbers. You keep the base, which is 4, and add the exponents. Alright, we're not going to multiply that out, it's kind of big, we're just going to keep it as 4 to the 5th power. Next thing, quotient, meaning divide. When dividing, again, that same base, keep the base, subtract the exponents. Right, so I have the same base, which is x, and I subtract 8 minus 5 is 3. Why does that work? Well, if I have 8 x's on top and 5 on the bottom and I was reducing, I'd reduce everything except for 3. That's why that works. Okay, same thing with numbers. Keep the base, subtract the exponents. And that number's small enough, if I wanted to answer it, say it's just 25, I could. But I certainly would not want to know what 5 to the 13th power is, and then what 5 to the 11th power is, and then divide it. Yeah, you could do it with a calculator, but without one would be very difficult. But if you know your exponent properties, don't need a calculator. Alright, third property, the power property. When raising a power to a power, keep the base and you multiply the exponents. So keep the base, multiply. Keep the base, multiply. Right, so we have three properties. Again, you can add exponents, you can subtract exponents, and you can multiply exponents. But these first two rules, you have to have the same base. And on the third one, you're just talking about one base, but more than one power. Now this fourth property, I'm going to call it the distributive property, but it really is just the power property kind of on steroids. It means that you're going to apply the power property to more than one thing at a time. So we're going to keep x and we're going to multiply those exponents. We're going to keep y and we're going to multiply those exponents. So it's kind of like a distributive property. Now here, this is one a lot of people miss because they don't leave, they think, oh, I do it to the x's, but I don't do it to the numbers. That 2 is raised to the first power. So I want 2 to the third power and x to the 18th. Now since that's small enough, I could go ahead and calculate that out. 2 times 2 is 4, times 2 is 8, x to the 18th power. So those are our properties. You need to know them. They're not going to go away. I'm still reminding my calculus students of these exact properties. And yeah, sometimes they get them wrong. Now let's see if we can apply these properties. The first part is we're going to evaluate expressions. Now when you see that word evaluate, that means you're not going to have letters as answers, you're going to have numbers, right? So they're meaning what do these equal to? Right, so the first one, what is 3 to the third power? Meaning what is 3 times 3 times 3? Well, 9 times 3 is 27. Okay, the second one is negative 2 times 2 times 2 times 2. We do that negative last. Okay, we figure out what that is and then make it negative. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So the answer is negative 16. Now number 3, just like I talked about up there, what the base is. This means negative 2 times negative 2 times negative 2 times negative 2. Now what happens when you multiply a negative times a negative times a negative times a negative? If you have an even amount of negatives, your answer is going to be positive. Okay, if you have an even amount of negative signs. Right? It's negative if you have an odd amount of negative signs. So we know the answer is positive and then positive 16. Just to tell you, those kind of problems you will definitely see something like on the next test. I want you to make sure you know what the difference between what the base is. So here the base was just 2. Here the base was negative 2. It does make a difference. Let's look at these next ones. We're still evaluating, meaning I'm getting a number. Now, number 4 is trying to trick you into using some property of exponents that doesn't exist. There's no property, go back and read it, that says if you have the same base with an addition sign. Not one property, and there's not in any other math book, all right? So, we have to go through order of operations. We figure out we're going to do the exponents first and then add. So we just figured out what 3 to the third power was. I think that was on problem number 1. That's 27. And 3 to the fourth power would be 3 times 3 is 9. 3 times 3 is 9. That's 81. And then I would add those together. So I would get 108. So I didn't use any properties because there just doesn't exist. Now number 5, I have the same base being multiplied. I do have a property. It says I can keep the base and do what with those exponents? Add. That's right. But then go ahead. These numbers are small enough that you should be able to figure out what that is. All right, so 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Now number 6, we have different bases. We don't have any properties with different bases, so again we just have to do the math in the right order, do the exponents, and then we have multiplication. So 2 squared is 4, 5 squared, 5 times 5 is 25, then we multiply those together and we get 100. Really testing your knowledge of those properties and how to apply them. Now number 7, what is this? This is the base. This means 3/5 times 3/5 times 3/5. Well, it's going to be a fraction. You multiply those on top. Well, we've done that 2 other times. 3 times 3 is 9, times 3 is 27. On the bottom, 5 times 5 is 25, times 5 again is 125. And it's not going to reduce because the base couldn't reduce. None of those reduced. So this is the final answer. Now what about number 8? Could I work number 8 the same way I worked number 7 and figure out what 2 to the 7th power is? Yes, but I don't need to. I have rules. I have properties. It says if I have the same base and I'm dividing, I can keep the base and subtract the exponents. Well, I'm looking at number 5. That's the same exact answer, so I know that's 32. Okay, keep the base, subtract the exponents. Number 9, again, we could do this a couple of ways, but let's use those properties. It says if I have a base and I have a power to a power, I can multiply. So 2 to the 6th, well, if 2 to the 5th is 32, times 2 is 64. So I know that was a little fast. Just go over it, think about what properties you can use, and don't make up new ones. Now the next section you'll see X's, because now instead of evaluate, you have the word simplify. Simplify implies you cannot just get a numerical answer. Again, we're looking at properties of exponents. So number 10, we have the same base being multiplied. So the property says I can keep the base and add the exponents. But hey, what exponents is here? There's an understood 1. So that's going to be x to the 16th. That's all you do. Now here, you could rearrange this. That's really 2 times 5 times x to the 7th times x to the 9th. Remember, you can multiply in any order. So I can multiply the numbers, and then I'm going to use the same rule here that I did over here. Keep the base and add those exponents. Let me write that a little bit better. Number 12, I could multiply there, but let's work inside the parentheses first, because since I have the same base being multiplied, I can keep the base and add those exponents. That's the same rule property I used on number 10 and number 11. Kept the base, added the exponents. But now I have another property. Now I have one base, a power to a power, and I can multiply those exponents, and I get x to the 77th power. All right, number 13 is kind of that distributive property. We have 3 different bases, and remember there's an understood 1 on that y as a power. So I want to multiply all my powers times 6. So I have x to the 12th, y to the 6th, and z to the 36th. That's it. That's all you can do. Number 14. Look at that fraction. It cannot be reduced. So what do we have to do with it? We have to raise everything to the 3rd power, including the number. So I need 3 to the 3rd power. I need x squared to the 3rd power, meaning I'm going to multiply those. And then I'm going to keep y in the denominator and multiply those exponents. And then the only thing I need to simplify is that. And you're done. Just make sure if you have something like this, that this 3 goes to all the parts. Okay, let's look at these last 2 examples. They're a little bit harder. Okay, so let's look inside here. I don't have any of the same base, so I need to distribute this 4 as an exponent. So I need 4 squared, x to the 16th, y squared. Remember, we're multiplying those exponents. Then I'm going to do the same thing on the next part. Remember, this is just multiplying, a parenthesis next to a parenthesis. So that's x to the 18th and y to the 6th. Again, multiplying. Okay, keep going. Now I have some same bases to deal with. So what's 4 squared? 16. Put your x's together, keep your base, and add the exponents. I'm adding 16 plus 18 and getting 34. Keep my y's, and add those exponents 8. All right, take it a step at a time. Number 16 is really like number 15, except instead of multiplying, we have division. So we're going to do exactly the same thing. I'm going to take this 5 and I'm going to make it go to everything in that parenthesis, including the 2. So again, multiplying those exponents. On the bottom, the 2 is going to go to all of that part. All right, let's do those numbers. Let's simplify those numbers first. What is 2 to the 5th? We've done it twice now. That's 32. And 4 squared is 16. So we know we can reduce those. So I'm just going to go ahead and copy down the rest of the problem. Okay, now I'm going to see, can I reduce more? Can you reduce 32 over 16? Sure. 16 goes into 32 2 times. Now you could put a 1 there if you wanted to. Now what about this? Do I have a rule about the same base being divided? Yes, I do. It says keep the base, subtract the exponents. Subtract the exponents. Same thing here. Have the same base, which is y, and I'm going to subtract the exponents. So since all of those have a denominator now of 1, I don't need to write that 1. I would just write 2x to the 13th and y to the 20th. Knowing these 4 properties, very important throughout your math career. Once you quit taking math classes, I guess you could quit doing these, but you really need to make sure you know them.